Chapter 2, Polynomial, Session 3. Let's start. Here, Reminder Theorem. We need to know now the Reminder Theorem. So, what is Reminder Theorem? See, for example, if I write down here 17 and I divided it with the 3, right? So, it is nothing but the 3 5s are 15. 3 5s are 15. So what is the remainder? So remainder is nothing but the 2. So now how you can write down this? So it is simple. So 17 is equals to 3 5s are. So 3 into 5. 3 5s are 15. But what I want is 17. So we need to add the remainder plus 2 plus 2. If I say this as a P quotient Q divisor G and remainder R. So how can I write this? Okay, see, if I write down here P, here divisor G, quotient Q and remainder R. So how can I write it down? So P is equals to G into Q plus R. So this is the generalized formula. This is also very much important and used in the standard 10 chapter number 1. So there is a formula. With the help of this formula, we are going to solve so many sums. So I hope this is the simple concept that you know till the standard 5, but here we can write down in the generalized form. Okay. Now let's move ahead. Example. Divide p of x by g of x, where p of x is this and g of x is this. Now the thing is how you can divide. So this is called the division method. So how you can divide it? So the very first step, I write down here. So this is the 3x square plus x minus 1, and here x plus 1. So very first step is what? The 3x square divided by x. 3x square divided by x. So here x and x cut. So what is remain is 3x. So 3x goes into the quotient. So here it is 3x. Now what you have to do is multiply this 3x. Simply write down here the 3x in bracket this x plus 1. Now 3x into x, 3x square, 3x into 1 plus 3x. In the division we know we need to do subtraction. So minus and minus, this is cut. So here what is remaining? Plus x minus 3x minus plus x 3x minus 2x minus 1. Now the second step is same. Minus 2x upon x, minus 2x upon x. So minus 2x upon x is nothing but the minus 2. So minus 2 goes into the quotient. So minus 2. Now what you have to do is multiply minus 2. So what you have to do is right now, so it is simple. So minus 2 into x plus 1. So minus 2 into x plus 1 is what? It is nothing but the minus 2x minus 1, because minus 2 into x minus 2x and minus 2 into 1 minus 1. So here minus 2x minus 2. Here it is by mistake, here it is 2. Okay. So here it is 2. So here it is going to be the plus and here also plus. This is cut. So what is remaining? So remaining is plus 2 minus 1 is plus 1. So plus 1 is the remainder. Okay, so this is that simple. Once again I am repeat this because this is very much important. So very first step you need to write down this, what the 3x square plus x minus 1. Now the first step is here x plus 1. The first step is 3x square upon x. X and x cut. So what is remaining is 3x. So 3 goes into the quotient. Now what you need to do is, now what you have to do, 3x into x plus 1. So 3x into x, 3x square, 3x into 1, 3x. That you write down over here. Then minus, minus. This is cut. So here what is remain is minus 2x. Right, and here it is minus 1. Now we want to do the same thing. Minus 2x upon x. So minus 2x upon x, x cut, answer is minus 2. So minus 2, here it is 2. So minus 2 into x plus 2. So minus 2x and minus 2. Right, minus 2x and minus 2. So here it is cut it out and here it is going to be the 1. So remainder is what? 1. Remainder is what? 1. Okay. Now let's move ahead. Now see, it is the dividend, right? See here, if I write down here P, G, Q and remainder R. So this is the divisor, this is the quotient, this is the dividend and this is the remainder. Simple. So dividend is equals to what? The divisor into quotient. Divisor into quotient plus remainder. So in general, if p of x and g of x are the two polynomials such that degree of p of x is greater than or equals to degree of g of x, where g of x is not equals to 0. Why g of x is not equals to 0? See, because if I write down p upon q, right, if divisor is becomes 0, the term goes infinite. It is g. Term goes infinite, so it never becomes 0. It is generalized thing. Wherever you find out anything, whatever there is in the denominator, you simply say denominator can never be 0. Denominator can never be 0. That thing you need to keep in mind. And here, what does it mean? See, this is very much important thing, that degree of p of x is always greater than, or you can say equals to, the degree of g of x in the polynomial. So see here, I am going to the previous slide. See here, see what is the degree of p of x? The degree of p of x is 2. What is the degree of g of x? It is 1. And what is the degree of r of x? 0, because it is a constant term. So here you need to keep in mind that the degree of g of x, that is 1, is always greater than the degree of remainder. Is it clear? See here, the degree of p of x is always greater than or equals to g of x. That is the one thing. Okay, that is the one thing. See here, the degree of g of x. The degree of g of x is what? 2. Degree of p of x is what? 2. Degree of g of x is what? 1. So it is always greater than, or you can say it is equals to, because if you can write down x square divided by 2x square, so both have the same degree, right? So it might be a greater than, or it might be a less than. It might be a greater than or equals to. Now g of x is not equals to, okay, that I can explain. Then we can find out the polynomial q of x and r of x such that, right, that we are already talking about here, and that is p is equals to g into q plus r. But here it is written in the form of, so here I can write down it is p of x. P of x means what? The variable is x. If I write down p of y, then it is in the variable y. So g of y into q of y plus r of y. So in that manner, where the r of x is equals to 0, the degree of r of x is less than the degree of g of x. This is important. This is important. This is important. So these are the very much important theory. It might be so many questions asked from this theory in the short questions. So understood this theory very well. See, we have three things: p of x, g of x, r of x, and q of x. But here what we need is these three things: p of x, degree of p of x. The degree of p of x is always greater than, or you can say equals to. It is always greater than or equals to the g of x. What? The degree of g of x. The degree of p of x. The degree of p of x. The degree of g of x. And the degree of r of x. Okay? So it is always greater than or equals to. It is always greater than or equals to. But the degree of remainder is always less than, or you can say the degree of g of x is always greater than the remainder, right? The degree of remainder is always less than the degree of divisor, or you can say the degree of divisor is always greater than the degree of remainder. Both are the same thing. I just changed the sequence. Okay, so this thing is very much important. See here the degree is 1 and here the degree is 0. They never be equal, because here we can say they are the degree equal, but if it is equal, we can do ahead also. We can do the sum also, right? So this is the thing. Once again, degree of p of x is greater than or equals to the g of x. Degree of p of x is always greater than or equals to the degree of g of x, but the degree of g of x is always greater than the degree of r of x. Okay, remember. So this is less than or equals, but here it is always greater than the remainder. Keep this in mind. Here we say p of x divided in quotient remainder. Okay, that is fine. Now, some examples, let's see. Find out the remainder when this is divided by x plus 1. But see, listen, to do the division method, it is a very lengthy process, right? If you don't want to do the division method, so how can you solve it very easily? See, one thing, when you have to divide it with this, so simply compare it with the 0. Assume that it is a 0 of the polynomial. So x is equals to 1. Now put this x is equals to 1 in this, right? So instead of x, I put the 1 everywhere and I got the remainder 2. This is always the remainder, right? If you want to check, let's check in the first example. It is x plus 1. So it is x is equals to minus 1 because 1 goes on to the another side. So it is minus 1 square plus minus 1 minus 1. So 3 minus 1 square, 3 as it is. Here minus 1 minus 1 minus 1 minus 1. So 3 minus 2 is equals to 1. And see here 1 is the remainder. Okay. So in that manner we solve this sum over here. So how? In this manner. P of x is what this. So instead of x we need to put the 1. So 1 to the power 4, 1 to the cube, minus 2, 1 square, 1 and 1. Right. So 1 power 4 is nothing but the 1. 1 cube is nothing but the 1. 1 square is nothing but the 1. But 1 twos are 2. And here plus 1 plus 1. Plus 1 plus 1. 2 minus 2 plus 2. Plus 2 minus 2 0. Remainder is 2. By the remainder theorem, 2 is the remainder when this polynomial is divided by x minus 1. And now let's start exercise 2.3. Find out the remainder when this polynomial is divided by x plus 1. We need to take the same polynomial throughout this question number 1. So here we have x cube plus 3x square plus 3x plus 1. Now here we need to check whether x plus 1 is what is the remainder when x plus 1 is divided. So x plus 1 is equals to 0. So that implies x is equals to minus 1. So instead of this x, what I have to put is minus 1. So minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. Now minus 1 cube minus 1. Minus 1 square is plus 1. So 3 as it is. Now 3 into minus 1. This is minus 3 and plus 1 as it is. Plus 3 minus 3, 0. Plus 1 minus 1, 0. This is equals to 1. Say if the remainder is 0, we can come to the some conclusion while solving the sums. Right. So here what we conclude is, if the remainder is become 0, if it is 0, then x plus 1 is the factor of the given polynomial. If the remainder is 0, then x plus 1 is the factor of the given polynomial. If it is not equals to 0, then given polynomial is not the factor of the polynomial with which we divide it. Okay. So in that manner you can conclude. If you want to write down it as a note, just write it down. While dividing with the remainder theorem, if the answer is 0, then we can say the given g of x is the remainder of the p of x. Okay. If it is not equals to 0, then it cannot be a factor. So here it is 0. So this x plus 1 is the factor of the given polynomial. Now, whether x minus 1 by 2 is the factor of the given polynomial or not. So polynomial is what? The same. Here I write down here. So x minus 1 by 2 is equals to 0. So x is equals to 1 by 2. So x is equals to 1 by 2. So instead of x, you need to put the 1 by 2. Here I put it here. 1 by 2 cube plus 3 into 1 by 2 whole square plus 3 into 1 by 2 and plus 1. See, 1 by 2. In the chapter first we see, right, in the chapter 1 we see cube is there. So it is of the 1 and 2 both. So 1 cube upon 2 cube. So what is the answer? 1 cube, 2 cube. So 1 as it is and 2, 8. Okay. In the same manner, here 1 upon 4, 1 upon 2 and 1. 1 upon 8. Here, see 1 upon 8 plus 3 upon 4 plus 3 upon 2 plus 1. So what is the LCM here? So LCM is 8. If it is 8, you need to multiply here with the 2, divide with the 2, here with the 4, and here with the 4, here with the 8, and here with the 8. So here 1 as it is. Now 3 2s are 6, 4 3s are 12, and 1 8s are 8. Right, see here. I will take the directly LCM over here. So this is the thing. So 1 plus 6, 7, 7 plus 8, 15, 15 plus 12, 27. So answer is 27 divided by 8, which is not equals to 0. This is for the sake of knowledge that you need to keep in mind, because it is very much important as far as your SSA is concerned. In standard 10 chapter 1st, you are going to face these things. If the remainder is not equals to 0, then we can say, so this is the remainder, our sum is over here, right? By the remainder theorem, 27 by 8 is the remainder of this equation. But if you ask something else, whether x minus 1 by 2 is the factor of this polynomial or not, that is also comes into the exercise 2.2, right? Whether this is the polynomial of this equation or not. See, right here, if it is not here, it is not equals to 0. Therefore, it is not the polynomial. It is not the factor of the given polynomial. Okay. Now let's move ahead with the another sum. Here it is only x. Here it is only x. If it is only x, we need to put the 0 instead of x. We need to put the 0 instead of x. So I put it here. What is thing is remain is only 1. 1. Why the remainder theorem? It is 1. So what we can say is remainder is 1. So it is by the remainder theorem, 1 is the remainder when polynomial is divided by x. It is equals to 0? No, it is not equals to 0. So x is not the factor of the given polynomial. Fourth question is x plus pi. So we need to divide the given polynomial with the x plus pi. So what we need to do is we need to compare x plus pi with the 0. If pi goes on to the another side, it becomes minus. So x is equals to minus pi. So we need to put this minus pi, instead of x. Right. So x cube, so minus pi cube. X square minus pi square minus pi and plus 1 as it is. Now see here, minus odd time minus pi cube, minus even time plus 3 pi square, minus 1 time odd minus 3 pi, and here it is plus 1. Right. So by the remainder theorem, minus pi cube plus 3 pi square minus 3 pi plus 1 is the remainder when this polynomial is divided with the x plus pi. Okay. Now let's move ahead. See here, in this equation, see it is 5 plus 2x is equals to 0. If 5 goes on to the another side, it becomes minus 5, and 2 from the numerator goes into the denominator. So x is equals to minus 5 divided by 2. So x is equals to minus 5 by 2. So instead of x in this polynomial, instead of x, we need to put the minus 5 by 2. So minus 5 by 2 cube, minus 5 by 2 square, minus 5 by 2. Now 5 cube, 125, 2 cube, 8. Now minus sign, odd number of time, that is my answer is minus. Now 25, 3s are 75. See, 3 into minus 5 by 2 square. Now 3 into 25 by 4. Now 70 or 25 3s are 75 and divided by 4. Here 3 5s are 15 divided by 2. Now what is the LCM? LCM is 8. So multiply by here. Here you have to multiply 75 with the 2. 15 with the 4. 15 with the 4. So now 75. 2s are 150. 15 4s are 60. Now divide this, add and subtract this. So minus 125 plus 150 minus 60 plus 8 divided by 8. Minus 125 plus 25, 25. Now 25 minus 60 plus 8. Now 25 minus 60 is what? 25 and 35. 35 minus 8. It is in the middle 27. So it is minus 27 divided by 8. So by the remainder theorem, minus 27 by 8 is the remainder. See here, this is not equals to 0. This is not equals to 0. If it is not equals to 0, then what we can say? That 5 plus 2x is not the factor of the given polynomial. 5 plus 2x is not the factor of the given polynomial. If it is equals to 0, then we can say it is the factor of the polynomial. But if it is not equals, here it is not equals. Now in this question, we need to divide this polynomial by x minus a and we need to find out the remainder. So in this polynomial, we need to put the x minus a is equals to 0 and therefore x is equals to a. X is equals to a. Now put the x is equals to a. Put the x is equals to a instead of x. Now a cube minus a into a square plus 6 into a minus a. Now a cube, a into a square minus a cube plus 6a minus a. This is cut. So what is remaining is 5a. Right here. So this is the 5a. So by the remainder theorem, 5a is the remainder when this polynomial is divided by x minus a. Here we simply need to find out the remainder, that's it. If you want to find out the remainder, don't go with the long division method because it is a lengthy process. If you are asked this question in a 1 mark, it is simple 2-step sum. Okay, so this kind of a sum may be asked in a 1 mark question, so you need to take care of. Now let's move ahead. This is the last sum for today. Check whether this is the factor of the polynomial or not. Simple. If it is equals to 0, it is a factor. If it is not equals to 0, it is not the factor. Now compare 7 plus 3x with the 0. 7 goes on to the another side. 3x is equals to minus 7. X is equals to minus 7 divided by 3. Okay. Instead of x, why I have to put 7 by 3? Here minus 7 by 3. 7 cube 343. 3 cube 27. And 7 sevens are 49 by 3. So minus 343 minus 147 minus 590 divided by 9. Right? You take the LCM. Here you need to multiply with the 9 and here also with the 9. Right? So you will get this is not equals to 0. This is not equals to 0. If it is not equals to 0, then this is not the polynomial. This is not the factor of the given polynomial. Okay. So that's it for today. We will meet into the next lecture. Till then, work hard. Bye bye.